Python, script compilation and execution. Understanding a computer. Computers are powerful computational devices that allow an agent person to send information input into the machine and achieve a goal to obtain output by utilizing the technologies CPUs, GPUs, HDDs, etc. embedded and integrated into it. It is said that the overall tasks performed by a computer may be summarized into three main steps. Number one, input. The process of the agent, human being, sending instructions, information into the computer, with the information transfer being facilitated via input devices such as a keyboard and mouse. Number two, process. The internal logical manipulation and transformation of the input. Number three, output. The altered and interpreted form of input that will be provided to the user of the computer, often via the main display screen. It is informative pieces of information that is the end result of the computer's process. Computer interpretation and communication. Computers, just like human beings, need to and are able to speak and converse with each other. In the same way that we make use of languages such as English to facilitate the flow of information to each other, computers utilize a language called binary. The CPU, brain of the computer, only speaks binary. Binary is a language that is used to communicate with the hardware of the computer. Binary language is one that comprises just two values, integer zeros and ones. The language that computers and associated devices speak is called machine language, and the machine language is created from machine code. An example of machine language or machine code is binary language. It is interesting to note that machine language and machine code are the same. So when an individual refers to machine language and or machine code, he or she is simply referring to binary language. To provide you with more insight, just like how we speak English language, which arises from the alphabet, 26 letters, it is logical to think of machine code as being the alphabet of machine language. That alphabet comprises just two values, integers, which is 0 and 1, from which the machine language arises. Binary language, or any other language for that matter, that computers speak is called a low-level language. It is a language that human beings cannot interpret nor understand. A low-level language is one that the CPU of a computer is able to speak and not human beings. A high-level language is one that human beings are able to speak and not computers. Hence, Python is an example of this. With that said, if a human being is unable to speak binary and the computer unable to understand English, this brings a question to mind as to how would we facilitate communication between a human and computer. This is where programming languages prove to be useful. A programming language will facilitate easy communication between human and computer by enabling the user to converse in their language similar to English and the computer in binary. The programming language will be responsible for facilitating the process of number one, converting high level language code into another high level language code, or number two, converting high level language code into low level language code. This is the conversion we will require from the Python programming language. The reason for conversion is the same, to create a program that is able to be executed and provide users with information. The Python programming language conversion. As we may know, there are several programming languages that exist in today's times. Therefore, we have several ways to communicate with our computer's CPU and internal components. However, all programming languages are not the same. They differ in terms of the syntax, that is, the language structure. Every programming language software will have two main additional softwares integrated into the programming software package, namely, number one, a compiler. This is the software that will do the conversion, translation of code written in one programming language into another higher or lower level language. In our case of Python, the compiler will convert Python code into a low level language called bytecode. Bytecode is low-level code that an application interpreter can understand. The compiler will compile the entire script in a single instance. Number two, The interpreter. This is the portion of the software application that will interpret the bytecode, therefore allowing for the program's output to be pieced together and displayed to the user. The interpreter cannot understand your raw Python syntax. It will require that the compiler first transform your syntax into bytecode. From the bytecode that is generated by the compiler, the interpreter will be able to generate the program output. The interpreter will interpret a single line of bytecode, one at a time. The reason as to why compiled languages are faster than interpreted languages is because a compiled language will be directly converted into machine code, binary, for the computer to understand, while an interpreted language must first be converted into bytecode and then to machine code. Hence, C++ is a good example of a compiled language and Python is a good example of an interpreted language. The name of Python's interpreter is the PVM, Python Virtual Machine. It is often called the Python interpreter. In a compiled programming language, C++, the conversion from source code into machine code is done before execution. In an interpreted programming language, Python, the conversion from bytecode into machine code is done during execution. Before moving forward with our tutorial, I would like to mention that our foundation of programming languages, particularly Python, is shaping up very well. Now, to effectively boost your understanding of the way in which a Python script is executed, I will provide you with a simple flow diagram. Python script execution. Number 1. Python file script with source code. Number 2. Python file is run, executed. Number 3. Compiler converts Python syntax into bytecode. Number 4. Entire script gets converted into bytecode, stored in a file called a PyCache file. Number 5. Interpreter software will begin to interpret this bytecode in a line-by-line format. Number 6. Interpreter will gradually turn each line of bytecode into machine code, binary. Number 7. The binary language format that arises is spoken by CPU, which will display output of the program to the screen. Conclusion. We have successfully gained insight into the way in which a Python script is executed. To achieve the above goal, we have understood low-level languages spoken by computers, high-level languages spoken by human beings, the language that a computer's CPU and internal components speak, binary language, the additional software programs that come with IDE software for programming languages, compilers, and interpreters. We have understood and noted the difference between compilers and interpreters, the purpose that a compiler and interpreter serve when programming. We also looked at logical flow diagram to obtain a concise higher level of insight into the compilation and execution processes when a Python script is run. Our next tutorial will mark the beginning to our journey of coding in the Python programming language. Thank you. The Python programming language. The aim of this tutorial. The aim of this short tutorial is to get one introduced to the programming language known as Python. As with any development or learning process, the foundation is most important. Within this tutorial, we will cover the basic concepts of the Python programming language. We will be introduced to important concepts and explanations which will facilitate your understanding of this programming language, its syntax, use cases, and more. What is Python? Python is a very popular, powerful, general-purpose, dynamically typed, open-source programming language that is used in present times. General purpose means that the language itself is so versatile that it is able to be integrated and proves to be useful in several modern-day fields, from medicine to development and architecture to designing and production. We will explore more of these concepts as we proceed further into the tutorial. Open source means that there is no formal license that governs the usage or distribution of this programming language. One may use and distribute the software at one's will. It is free for the public to use. In open source software license legislation, the users of the software need not pay to utilize it. The creator of Python is Guido van Rossum. Please may I be excused if I am pronouncing the name incorrectly. He created the programming language on 20th February 1991. Upon obtaining experience in this programming language, one can tell that Guido van Rossum has done exceptionally well in creating a programming language that is liked by everyone around the globe and which is able to be so versatile in its use cases. In this tutorial, I will be working with Python programming in a Windows 10 environment. However, Python programming language can be run on just about any operating system. Four common operating system environments on which Python is run are Windows, I will be using this operating system, Linux, Mac operating system, and Raspbian. Why use Python? It is a versatile programming language. It offers high power computation. It is simple to understand the syntax. It is open source software. It is used by large modern day corporations, Facebook, Netflix, Google. Ability to utilize functionality from dependencies, packages, and libraries. Used in a variety of popular fields: machine learning, data science, robotics, and automation. Overall, a good first programming language to get introduced to the world of programming. Provides immersive and fun learning experiences, as we will see in the near future. Selecting an IDE. An IDE, Integrated Development Environment, also often called the IDLE, Integrated Development and Learning Environment, is the environment or software space in which you will proceed to do your coding or programming. Think of it this way. You have a pot of biryani, the entire programming language, the code, additional resources, etc., and it's time to serve it on a plate. IDE. There are several plates, IDEs, from which you need to choose a specific one to hold your food, programming code. Within this IDE, you will create programming scripts which will house your code. You will do physical programming within this environment. One will proceed to create, develop, and maintain their code within this environment. Just like how you have options for plates on which to serve your food, one will have several IDE options. You need to take time to work through a few, and eventually you will find the one that suits your preferences. At the highest level, they will only differ in design and methodology. That is, the process in which a task is performed. Example being, the way in which a file is installed or saved in one may differ from the next. Their main purpose, however, is common: to provide a well-built, powerful Python programming environment to software developers. A few of the many commonly used powerful Python IDEs are as follows, in no particular order. To download the software, you may type the corresponding hyperlink in your browser of choice. Integrated Development Environment, Web Hyperlink. Python idle, recommended for beginners. Spider IDE, recommended for beginners. Link for Windows machines. Eclipse, Jupyter Lab and Jupyter Notebook, recommended for beginners. Wing IDE, Visual Studio. Atom, link for Windows machines. If you would like to download multiple IDEs on a single physical machine, you may go ahead and do so. The more experience you get with the various software, the greater your understanding of IDE software will be. If you are a beginner, I highly recommend utilizing the popular distribution of Python and R known as Anaconda. Anaconda is a package of several types of data science tools and softwares that particularly focus on the Python and R programming languages. It contains several tools such as Jupyter Notebook, Jupyter Lab, PyCharm, Spider, and much more. Anaconda can be seen as your shopping bag, which contains several high-quality tools that can be used for Python and R programming languages to perform tasks such as machine learning, data science, automation, and more. All the items contained in this shopping bag are free to download and use. One particular software that the Anaconda distribution contains, which we will require, is the Spider IDE, one of the many software development environments mentioned in the previous slide. If you would like to download the Spider IDE only, please visit this link. If you would like to download the entire Anaconda distribution package, please navigate to the link below. Understanding programming language properties. As one may already know, there are several programming languages that exist in today's times. With that being said, When a collection of properties are gathered from all programming languages, there are a lot that can be seen. The properties of a programming language are called the programming language paradigms. A paradigm, can be thought of as a feature or property, and in our case, it is an attribute of the programming language that conveys to us the various different types of programming that it supports and that one may employ when actually coding in a script. There are a lot of programming language paradigms that exist, a few of which are mentioned on the next slide. We will only discuss the paradigms that the Python programming language utilizes. I am aware that one will not exactly understand how the paradigms lend themselves to the language itself, since we have not yet programmed in Python. However, I shall explain it simple enough for you to understand the main concepts. Knowing that the language holds these properties will greatly increase your understanding of the programming language and the efficiency of your coding when physically implementing our learnings. Examples of programming language paradigms: logic programming, object-oriented programming, functional programming, procedural programming, stack-oriented programming, data flow programming, generic programming, imperative programming, reactive programming, array programming, function-level programming. The main Python programming paradigms. The major paradigms of Python and their associated explanation are as follows. Number 1. Object-oriented programming. This programming paradigm refers to real-world objects. It is the paradigm which states that any object in the real world may be represented as Python code in the form of a variable and may take on its real-world attributes. A good example would be being able to create an object car and assign and manipulate various properties of it, such as color, weight, dimensions, and so on. Simply put, any object in the real world is able to be expressed as an object in the Python programming language itself. Number 2. Functional programming. A function is a block of code. These are lines of code enclosed and kept together with a collective name. Upon calling the name of the function, we call on all lines of code within the function or block to be executed as well. The key aspect of a function is that all the lines of code within it work together to provide us with a computational output. To provide you with insight into an example of a function, think of our pot of biryani as the function name. Instead of carrying each grain of rice line of code, you can simply carry the entire pot with you, and when you carry the pot, you are calling on all the rice grains within to come together and work towards a common output. Number 3. Procedural programming. This simply means that every line of Python code is executed in an order of sequence, that is, a sequential order. Every Python script may be broken down into its constituents, that is, variables, lines of code, functions, and so on. Every Python script is executed in a fixed order. The script is compiled from top to bottom, left to right. This serves to make us aware that every portion of code in a Python script is there for a reason and serves a purpose. Every element, irrespective of memory size, forms a part of the higher level of processing and procedures. Example: in the same way that your daily life may be broken down into several tasks, waking up, working, and resting, and much more, all these activities form a part of the higher goal that you will achieve in the near future. Number 4. Multi-paradigm programming refers to a programming language that supports the object-oriented and procedural programming paradigms. As we have seen in the previous slide, Python does support this. Number 5. Structured programming. A paradigm that reinforces the fact that Python programming language syntax makes use of specific keywords and techniques that help to facilitate the building of a structure in each Python script that exists, and hence in the entire programming language itself. For example, a programming language does not differ largely in comparison to the languages that we speak. And just as we have to place certain words and phrases in certain statements and use cases, similarly, Python programs require keywords to be used in a way in which they complement each other, hence retaining structure and understandability of the language, thus maintaining smooth flow and readability. Number 6. Event-driven programming. Every Python script is compiled from top to bottom, left to right. This reinforces the notion that particular keywords that are encountered in particular instances of a Python script may cause the flow of the script at that particular instance to be overrode and may result in certain blocks of code being temporarily skipped, hence passing over the lines of code. This is the notion that event-driven programming aims to drive home. A relatable example would be the process of driving a car. Certain situations require that we temporarily skip a process and see to another before we continue the initial process. For example, when driving a car and upon reaching a decline, I assume one would not accelerate. I know I don't, but rather focus on and apply brakes. With that being said, due to the event or situation we are faced with, we have temporarily skipped over or passed one process and focused on another, upon which reaching flat ground we proceed to continue acceleration. End of main Python paradigms. Thank you. Installing the Anaconda distribution on a Windows machine. Installing our software package. If you have successfully downloaded the Anaconda software distribution.exe file, you will be able to search for it using the search bar in a Windows environment. This tutorial will focus on a step-by-step guide on installing the application and setting up the environments. The first task to complete is that of locating the anaconda.exe file that has been downloaded and thereafter opening it. You may follow any approach that is convenient to you. For example, you may simply left-click once on the downloaded file from the Chrome browser, or you may open your File Explorer, navigate to the Downloads folder, locate the Anaconda file and proceed to double-click on it to initiate the opening sequence, or head to the Windows search bar, simply type Anaconda and you will be able to see the anaconda.exe file. Left-click this file. Irrespective of the approach you use to open the anaconda.exe file, you might be presented with the following screen. If provided with the above screen, click Run. This file is safe to open and install on your machine. Now, the primary screen we aim to obtain is as shown below. This is the home screen of the Anaconda Setup Wizard. The wizard is here to assist us in our attempt to make a successful software installation on our machine. Proceed to click Next. You will be presented with the end user license agreements to the software. Read through the end user license agreement terms and conditions and click I agree if you would like to proceed further. The next screen will involve you selecting the appropriate installation option, that is, will you be installing the software for all users of a machine or just your particular account? In most situations, the default value is preferred. Click the Next button. On the Choose Install Location screen, it is recommended that you do not change the installation location. Leave the text in the destination folder as is. Click Next. The next screen will present you with advanced installation options. I recommend that you select both of the checkboxes. Check the box which says Add Anaconda 3 to my path environment variable. Next, click Install. Upon clicking Install, you will find that the software will begin installation. If you would like to see more details about the program installations, you may click on Show Details. Please be a bit patient during this installation process as it will take some time to complete successfully. Upon waiting a few minutes for the installation, you will be presented with the installation complete screen, which will reassure you that the entire software installation was successful. You will be presented with the screen seen on the next slide. Click Next. Proceed to click Next. Upon doing so, you will be presented with the screen on the next slide. The above image depicts the last screen that you will see for the installation wizard. Provided in this screen are additional resources that you may use to assist you in learning and becoming familiar with the programming software. You may select the checkboxes according to your preferences. Opening the Anaconda Navigator application. After making a successful installation of the Anaconda software, attempt to open the application via your search bar in the Windows environment. Head to your Windows search bar, type Anaconda, and open Anaconda Navigator, Conda 3. I recommend that you also select the option Pin to Taskbar. This will make it easier for you to locate the application. Upon opening the Anaconda Navigator, you will be presented with the following screen. Feel free to experiment with the various other software applications that are available for use within the Conda environment. Scroll as necessary to view the Spider IDE and click Launch. Please be patient while the software loads, as it will take some time to do so. Spider IDE is a powerful IDE that requires quite a bit of computer resources to function effectively. I will be running the application on an Acer i3 machine. When Spider has finished loading, you will be presented with the following screen. Click OK. Next, you will see this screen. On the Welcome to Spider screen, feel free to take a tour of the IDE in order to obtain a higher level of insight into the software features. We will explore a few of the important features during our journey with Python. Click the Start Tour button or click Dismiss. If you would like to add Spider IDE to your taskbar, simply navigate to your Windows search bar, type Spider, and select Pin to Taskbar. Conclusion. In this tutorial, we learned how to install the Anaconda distribution successfully. In the next tutorial, we shall begin our coding in Python and look at learning the fundamentals of the Python programming language. Thank you. Introduction to Python Fundamentals. Hello World. Beginning our journey with Python. If you have coded in any other programming language, you will realize that the first and foremost program that is introduced to a new learner is the Hello World program. The same is true with your journey with Python. If it is not the first program you code, it is one that you will definitely come across during your journey with the programming language. The Hello World program is the traditional way or norm in which an individual is introduced to the world of programming. Since it is how I began my journey of Python programming, I would like to begin our tutorial with this norm. To begin, load up your Spider IDE via Anaconda distribution or simply click the shortcut on the taskbar. Area for typing code in Spider. Within the Spider IDE, the area of the window in which we physically type code is called the editor. The editor is where all code belonging to a particular script will be typed. The code for a particular script is also referred to as source code. Source code is the actual code that makes up a particular program. For example, the Android operating system is open source, which means that anyone and everyone may download the source code free of charge and without any terms and conditions. Now, any source code comprises certain syntax that gives the entire script purpose, usefulness, reason for executing. Area for viewing output in Spider. The portion of the window in which we will be able to view program output in Spider is called the IPython console. IPython console stands for Interactive Python Console. It is referred to as being interactive because of the fact that it allows you to code Python in it and execute or run it from the same area. You may issue several commands input in this interactive console and view output in the same area. Try typing print hello world and then press enter. Our first Python program. Next, I would like you to open a new file and in any line of your choice begin typing print hello world. Now, save the file as helloworld.py. For this tutorial, I have created a new folder on my desktop and named it Spider Python Scripts. I am mentioning this because you may do the same on your PC to have all your scripts stored in a single convenient space. Next, run the script in Spider by clicking on the green play button. The Spider File Explorer for directories and subdirectories. The File Explorer pane is the portion of the Spider window in which you will see all the Python scripts that are in the same directory as the one you are working in. The File Explorer allows you to open Python files to view and edit source code. Notice that when we ran our hello-world.py program, the Spider File Explorer automatically navigated to the directory in which it is stored on our computer. Output of the hello-world.py program. The output of our first Python program will be seen in the IPython console, as can be seen in the image on the left. The output is text which says, "Hello world." If you are completely new to Python, well done, as this is the first line of Python code that you have written. If you have done Python before and are following along for educational purposes, well done to you as well. Let's keep going. Understanding our first line of Python code. Before we completely conclude this tutorial, I would like to speak a bit about the first program that we have created, hello-world.py. Despite being a short one-line program, there is actually much knowledge to take away from it pertaining to Python fundamentals. So essentially, we are speaking about this line of code, print hello world. You may have certain questions in mind pertaining to this line of code, a few important ones which may be: Number 1, why did we use the word print? Number 2, why is the word print in a different color, orange? Number 3, why is the text hello world enclosed in quotation marks? Number 4, why is the text hello world enclosed in parentheses? Number 5, why is the text hello world in a different color, green? Number 6, why have we specifically and only printed the words hello world? I explain this on the second slide of this tutorial. Number 7. Can I change the text within the print function to anything I want to print? I would like to say, all questions above and any I may not have mentioned are good questions to ask. I shall attempt to answer all to the best I can. Since we have written our first Python program using one line of code which uses important syntax, language structure and keywords, I would like to explain it to you. A gentle reminder that this is not the only instance in which we will speak about it. We will definitely cover more detail in the future. For now, this is just to enlighten you. Introduction to Python keywords. The word print is in a different color because it is a Python keyword. Keywords are specialized words that have been built into a specific programming language by its creators or developers. The Python compiler automatically identifies the keyword as a built-in word and therefore makes it more prominent on the screen by using a different color for it. Keywords are built into the programming language, which means that one cannot change or alter them in any way whatsoever. Each keyword has a specific purpose to accomplish a specific task. The print keyword is used to send and display text to the user via the output screen. As in our case, we wanted to print the text hello world to the console, which we have succeeded in doing. In Python, when you have a keyword with its own set of parentheses, round brackets, we refer to the keyword as a function. This means that it will take in some form of input and return some form of output. As in our code, it has taken in the text hello world and provided us with an output of hello world. When I am referring to functions in Python, you will see me attach a pair of round brackets to the keyword, just like print. Hence, I say the print function. Introduction to text and data types in Python. Notice that within the print function, we have passed in the text hello world with quotations included. Any text that is inserted within quotation marks in Python is referred to as a string. Strings are one of the many data types that is acknowledged by the Python programming language. A string is text. At all times in Python programming language, text will always be in the form of a string and enclosed within quotation marks. It is called a string because it is a sequence of characters. The print function can print any text to the screen as output. Text is not the only data type that it can print to the screen. If you are printing text though, you may change it to anything you like. For example, your name is great, smiley face. Having data types in a programming language effectively boosts the entire power of the programming language. A data type can be thought of as being a name tag for a piece of information that provides us with insight into the type of operations that can be performed on it. Different data types are used for different purposes and have different operations that can be performed on them. I would like to reinforce the importance of the information contained in the previous statement. To provide you with a higher level of insight into data types, I will provide you with a table of examples of important data types in Python and a short explanation. Data type, Python keyword, explanation, examples. Data type, string. Python keyword, str. Explanation. This is text. This data type is depicted by quotation marks. The type of quotation marks used does not matter, as long as the quotation in the beginning of the string is the same as the quotation used at the end. Strings are sequences of characters. A sequence means that there is order in the characters that make up the string. For example, if I were to add the string characters A and B, I would get AB. Similarly, if I wanted to add string 5 to 5, I would not get 10, I would get 55. Examples: print single quotations, print double quotations, print triple quotations, print 1.5 million years ago is a long time. For practice purposes, I recommend that you physically type the code in the examples column for all tables in your IDE to understand how these data types work. Data type integer. Python keyword int. Explanation. This is simply numbers. This data type is depicted by a whole number. It can be a positive integer or a negative. No quotations. As in mathematics, Python programming supports several operations for this type of data. A common operation can be one like addition or subtraction. Using integers, whole numbers, we can logically say that integer 5 added to integer 5 is 10. Hence, we can immediately see that the int data type will allow us to perform algebra and other complex mathematical calculations and processing. Examples: print 5 plus 5, print 1 million plus 1, 1 2 3 4, 1 3, 2 0 2 0. Data type, floating point integers. Python keyword float. Explanation. This is a subset of integers. This data type is depicted by numbers with decimal values. Operations supported are the same as integers, just that in this value there are decimal points to take into consideration. Examples: print 5.0 plus 5.00, print 1 million.0 plus 1.0, 1234.56, 13.2423, 2020.0001. Data type Boolean. Python keyword bool. Explanation. A Boolean value may be one of two predefined values in Python, true or false. They have a predefined syntax that cannot be changed. In Python, the Boolean value of true is equal to 1 and the Boolean value of false is equal to 0. In numerical representation, true is equal to 1 and false is equal to 0. Boolean values are very rarely used as a standalone value in programming. This data type is used in conjunction with other features of Python and exists to grant more functionality to the Python programming language, as we will see in the future tutorials. Examples: true 1, false 0. Conclusion. Well done. We have successfully learned about the basics that the Python programming language has to offer. I would like to mention that when you hear the term syntax in programming, it simply refers to the specific language and word structure of the programming language. As with our introduction, we have used Python syntax to write our first program. We have learned about the print function and have been introduced to important data types in Python programming language. As with any avenue in life, the only way to sharpen a skill is to practice it regularly. I will create simple exercises for you to work through to test your takeaways of this tutorial. Thank you for watching my tutorial, and I do hope that you have learned new concepts about the Python programming language. Thank you. Building on the Fundamentals of Python, Part 1. Introduction. In this tutorial, we will seek to explore more topics of the Python programming language. We will draw on concepts learned in the past and expand on them more. To have maximum takeaways from this tutorial, I recommend that you follow along in an IDE of your choice. From our previous lessons, we have been introduced to a few Python programming concepts, important ones being the print statement and data types. This tutorial will enlighten you about more functionality that Python has to offer. Let's get to it. Obtaining user input. If you remember correctly from our previous lesson, we have effectively learned how to print information to the screen for the user to see and read. It is interesting to note that there is a way in which you may ask the user for input in your program. You may ask for a variety of input such as strings, integers, floating point integers, and more. The keyword to utilize when input is required from the external keyboard is input. The way in which this is done in Python is as follows. If you run the single line of code shown in the image on the previous slide, you will see that output in the IPython console will show as seen on the right. There is no need to be alarmed if nothing is seen. This is the input function in its base form. The input function is effectively waiting for a user input. Now, click anywhere in the IPython console area of the screen and begin typing anything on your keyboard. But note that once you press enter on your keyboard, the input stream will end. I have typed hello world and thereafter pressed enter. We have effectively learned how to take input from a user of the program. However, the way in which the program requested for input has not been very accommodating because, as you know, in most forms of programs today, there are always text prompts that guide the user on what type of information to enter and exactly where it should be entered. With the input function in Python, we can effectively add text to create a prompt for the user to enter input into the program. In this way, the user will know what type of information to enter and exactly where to enter it. Let us see how to do this on the next slide. Looking at this image, we are able to see the same input function. However, in this particular instance, we have passed in text that says, please enter your full name. Now, let us see the output that the input function provides us when we pass in text to represent an input prompt to the user. Output will be seen in the IPython console as follows. Notice that the text we have passed into the input function is the text that is displayed to the user to serve as the input prompt, thereby specifying the type of information required and the place in which to type it. And once again, you may type in the required information and press enter. Reinforcing the concept of data types. If you remember correctly from our previous tutorial, Introduction to Python Fundamentals, Hello World, you will recall that we spoke about data types. We shall now elaborate further on this topic. You see, a data type is like a name tag for a piece of information. It is always attached to a piece of information. For example, if I ask someone for their full name, the information is the full name, and the data type will be of string. If I request an individual for their year-end final average, the information is the average and the data type will likely be a floating point integer, decimal. In the same way that we obtain insight into the operations that can be performed on real-world data when we know the type of data we are working with, Python programming language relies on knowing data types to make certain operations available to be performed on different types of data. For example, in the real world, I can add and find the average of student marks because I know for a fact that it is of numerical data type. However, In Python programming, I will be able to add and average the information only if the marks are in integer, whole number, or floating point integer, decimal number, data type. From the programmer's point of view, Python also makes coding and processing tasks a bit easier as compared to other programming languages, a good example being C++. I say this because in Python, we are not required to specify the data type of information. Python automatically identifies the data type that is tied to a piece of information. C++, on the other hand, requires that we explicitly make the data type of information known. We will build more on this concept in a future tutorial. Taking input from a user of a program is a very common activity in any program. It is what gives the program the ability of interaction. Regarding the previous point, however, there are certain instances in which we as programmers are required to specify the data type of input information that we require. A good example I can give you would be the scenario of requesting a user for their age. In this case, some would prefer to provide their age as a string, words, and others an integer, whole number. Maybe some would even use a floating point integer, a decimal number. But the main point is, what if we require the input as an integer, or a string, or a floating point integer? Specifying the data type of user input. If you recall from our previous tutorial, I provided a simple table that explains commonly used data types along with explanations and the Python keyword. If you recall or go back and check, you will see that the keyword for string is str and integer is int. So, the scenario I am giving as an example for the topic of specifying data type of user input is as follows. You may make the program output any message you would like to and ask for any input that you want to, as long as you understand the concept we are learning about. First, we want to print a message that says, "Welcome to Python," and thereafter, we would like to take two input, namely the user's full name and then the user's age. The full name needs to be in a string data type and the age in an integer. The program must not accept other data types. You will find it interesting to know that the default data type that the input function takes input as is a string. So irrespective of the input you request from the user, age, name, height, etc., it will be collected as a string. And we can back up this observation with a real-time example. Looking at the image on the previous slide, we are able to see that I have asked the user for two pieces of inputs, full name and age. The user has entered their full name correctly and their age. However, the age is not in a data type that we were expecting. The user chose to type their age as a string, and because the input function accepts any input as a default string data type, it has accepted the input provided. Therefore, we are logically required to effectively apply a check to the input provided for age. We need to reinforce the idea that the age needs to be in the form of an integer. To do this, the process is known as casting. Essentially, what this means is that you are converting one data type to another. Casting is a simple process that involves utilizing the keywords. We will attempt to create a program for our scenario as follows. Understanding the process of casting. Looking at the image on the previous slide, we are able to see a simple program as we have been doing in previous lessons. However, in this particular instance, we see that data type keywords have been used, specifically string and int. And we see that there is one more set of parentheses. Do you remember in the beginning of the tutorial I mentioned that when a pair of parentheses brackets is used, it means that the keyword is a function. Keep this in mind. Let us look at the explanations for this in detail. First, we have printed a welcome message to the screen using the print function. Next, we printed the words "to continue," again using the print function. The line of code on line 11 shows as follows: string input 1, please enter your full name. Notice that in the line of code above, we have used the input function to obtain an input of name, and thereafter we have enclosed the input function in the string function. The string keyword is a keyword that will convert input into a string data type, and in our case, it is converting the input that the user enters into a string data type. I am aware that using the string function is redundant, as I mentioned earlier that the input function by default captures input as a string by default. The same logic applies to the int function. This keyword will convert the input you provide into integer data type. The line of code on line 12 shows as follows: int input 2, please enter your age as an integer whole number. Looking above, we can see that we have used the input function and passed in a prompt that requests for the user age in the form of a whole number, integer. And to ensure data type specification, we have enclosed the input function in an int function, thereby successfully performing the process of casting. Essentially what happens is that the user enters input in a default string value, and then the int function tries to convert that input into an integer data type. You may be wondering when or how the specification works. Do experience it. Run your program while passing in any data type of input except integer for the age input prompt. Looking at the image on the right, this is the output I receive when trying to input the user age in the form of a string with the int function surrounding the input. The int function has successfully ensured that the input to be accepted is only of an integer data type due to the specification being provided. You see, in the same way in which our data type specification works, several web pages in present times utilize similar techniques. For example, you may have come across web pages in which you are signing up for a cloud service and are required to provide a password that meets certain criteria. However, instead of crashing or stopping, the web page simply refreshes or alerts you to make the necessary adjustments in the same instance. Notice that our program has failed to execute due to an error being encountered. By the user not providing input that is required and that meets criteria, the program will not continue to execute. As explained previously though, in the real world, programs cannot crash. Keeping the knowledge I have shared with you above in mind, as we progress further into the course, we will be introduced to more concepts, one of which will allow the program to not fail, but rather let or allow the user to have another try to enter the correct input and will ask for input until it is correctly provided. Conclusion. In this tutorial, we have successfully learned about the process of casting. Casting is a technique that is used to convert one data type into another in Python by making use of data type keywords that are built into the Python programming language. We have looked at how to set up the input function in Python to accommodate specification and checking of input that is provided by the users of the program. I shall create a short exercise for you to work through based on this tutorial. Thank you for watching, and I do hope that you have new takeaways about the functionality that the Python programming language has to offer. Thank you. Building on the fundamentals of Python, Part 2. Introduction. This tutorial will expand on more concepts of Python that may be classified as being beginner. Nevertheless, it is fundamentals that ultimately form the foundation of your learning, and hence it is important to grasp all the knowledge that you can. I am sure that you will find this lesson particularly interesting, as we will be exploring a topic that brings the touch of versatility and computation into the programming language. The focus of the tutorial, building on the fundamentals of Python Part 2, is variables. We will seek to explore the basics and complexities of this feature that the Python programming language supports. What are variables? As you may know, a variable in mathematics is a value that changes or may change over time. It is called a variable because it is not a constant. A constant is a value which will remain the same. Now, in programming, one of the most popular analogies for the explanation of a variable is a variable can be seen as being a container in which a piece of information may reside and be stored. Do you remember in a previous tutorial, I mentioned that every piece of information has a data type, which is like a name tag attached to it? Well, a variable is a place for us to store that information. This means that if the variable is thought of as being a container, the variable, number one, will have a name for us to easily identify it so we may retrieve the information stored in it. Number two, it will have a piece of information stored in it. Number three, the information will still retain its associated data type. Hence, indirectly, since the variable is storing the information that has a certain data type, the variable may also be referred to as having that specific data type as well. But, logically, a variable does not really have a data type because of the fact that it is named so, variable. To provide you with more insight into the concept of variables, let us assume that we were required to create a program that prints out a paragraph of text for students in a classroom. The code we have is as follows. Print, Jack is 9 years old. Print, Jack went to school today. Print, Jack is in grade 3. Print, Jack has a pet lizard. Print, Jack's favorite food is pasta. As you can see, we have several statements that speak about a student named Jack. The concerning point is that, suppose we have a class of 10 or even 20 students. Would we be required to manually change each statement to match that particular student's information? For example, what if there is another student by the name of Sarah who has the exact same information as Jack? One way for us to change the information to match Sarah's personality would be to manually change all instances of Jack to Sarah. It would be done as follows. Print, Sarah is 9 years old. Print, Sarah went to school today. Print, Sarah is in grade 3. Print, Sarah has a pet lizard. Print, Sarah's favorite food is pasta. This approach works, but it is not convenient for a programmer. This is where the advantages of having a variable comes into play. Improving our script using variables. We shall now use variables in our previous script to make our programming easier and improve the power of our script. To use a variable, we have to first create a variable. Creation of a variable involves three components: a variable name, assignment operator, and a value. Before we create our variable, let us think logically. We have a scenario in which we do not wish to keep going through statements to change the name of the student to match their personality. Therefore, we shall create a variable to hold the information of student name. This variable will have a name. It will have an equals to symbol to assign the value of Jack to it. Now, using the above logic, we will proceed to create a variable to hold the information for name of a student, Jack. We will do it as follows. Name is equal to Jack. Line number in spider IDE. I included that so you do not get confused. Name given to the variable equals to. Assignment operator equals to. The equals to sign will assign the value on the right to the variable name on the left. Jack. Value being assigned to the variable. Note, data type is automatically recognized by Python. That is, Python knows that this is a string. Now that we have created our variable, let us look at ways in which we can use our variable. But first, you need to understand the logic behind the feature that allows you to use a variable in your programming script. When our program is being executed, all variables are stored in the system's memory, RAM. As you may know, your computer has an internal hardware component called RAM, Random Access Memory. This is in the form of a RAM module, strip. We are not going into the detail here, but I will provide you an overall view of the structure of the RAM module. The RAM module has several cells that it is made up of. These are compartments. Each compartment has a physical address to assist with identification and navigation to a particular piece of information in it. Each compartment may be used to store information. Hence, having the physical addresses and compartments make it easier to store, locate, and retrieve information at will. And this particular property of RAM is exploited by programmers to reduce the physical coding that they are subjected to, as well as greatly increase the computational power of their programming script. Think of it this way: your fridge resembles a RAM module. It has compartments, cells. Each compartment, cell, can store a container, variable. This container can store information, biryani. This information has a data type, food. If you bring the container variable out of the fridge RAM, you are not only bringing the container variable, but you are also bringing the contents of it as well. The contents, which is information, biryani, of data type food. With the same logic in mind, in Python programming, when we execute our script, the entire script gets compiled and all variables in your script are stored into their own place in RAM for future use. As we know, the variable has its own cell and address in RAM. The interesting thing is that the contents of your variable may be accessed by the name that you give it. So, since we have created a variable called name, storing the information jack of string data type, when I call on the container called name from RAM, I will be returned with the output of jack. Go to your Spider IDE, create the variable if you haven't, and then print your variable name. View the output in the IPython console. Below, we have created the variable called name and we have assigned it to a string value of jack. We thereafter proceeded to print the variable to the screen using the print function. Name is equal to jack, print name. Upon running the script, your output to the above lines of code will show as follows in the IPython console. See, we are returned with jack, the contents of the name variable container in memory RAM has been emptied and returned to the screen. Excellent. You see, now that we have learned exactly how to actually store information from our program into system memory, we are effectively building up on the complexity of our program and increasing the processing power of our scripts. Because with variables, we will be able to store information, process it in memory, and then output it to the screen. Let us improve our student script. So, with the concept of variables in your mind, let us attempt to change our script to be more versatile and automated. You will find that as we learn about one concept, a new concept arises. For example, here you will be introduced to an operation that can be performed on string data type. It is called concatenation. To be specific, string concatenation. The name given to the process may sound difficult, but it is not. Concatenation simply means adding two or more strings to each other, thereby forming a single string. We can basically merge several strings into a single one. To do this, we use our well-known addition plus operator. I want you to understand this process on a slightly higher level. Head to your IDE and use a print function to print the sum plus of the strings A and B. The addition operator must be situated in between the strings and not be enclosed in any quotations. Please attempt this before you move on to the next slide. Adding strings, string concatenation. So, I requested you to find the sum of two strings, A and B. If you have attempted it, you will find you did something to this effect. Print A plus B. Line number in Spider IDE. Again, I added that so you do know that I am also using Spider IDE. The print function A. The first string I requested for was A, plus addition operator to perform addition of strings. B. The second string I requested for was B. You will see the output as follows: a single string AB. Do you remember when I mentioned that a string is a sequence of characters? It means that the final string which arises will be in the same order the substrings are given. In our case, A and B are substrings, and the final string created after concatenation is AB. Now is the time when I mention that spaces also count as being a part of a string. Spaces as in when the space bar is pressed. You see, the strings that we added, A and B, have no spaces in the beginning or end. I want you to see how strings work in Python. Navigate to your Python script where you performed string concatenation and add additional spaces in the string by pressing space bar. So, I mean, make the length of the string longer by adding spaces before and or after the string characters. You might have something different, but the point is, you have inserted additional spaces. Print A plus B. Line number in Spider IDE, I added that. Print function A, I inserted one space before A, plus B, I inserted one space before B. Output will show as follows. The main point for you to see and understand here is that strings will be added and outputted in the order and format that you provide. I have added additional spaces in the strings while coding, and you would have done the same. Therefore, Python has added the strings together while retaining these characters. Notice that because I inserted a space before the letters A and B, Python has added the strings A and B, therefore accounting for the space we see before A in the output and the space separating A and B in the output. Finally, coming back to this scenario, now that we have knowledge about variables and string concatenation, we may proceed to change our student script to make it more efficient. Take a moment to see what we have done below. Name is equal to Jack. Print name plus is 9 years old. Print name plus went to school today. Print name plus is in grade 3. Print name plus has a pet lizard. Print name plus S favorite food is pasta. Looking at the previous slide, one can see that we have replaced all instances of the string Jack with the variable called name. This variable stores the name of the student, and from our past experience, we know that when we print or call a variable, we are returned with its contents. Therefore, the output would be as one expects it to be. Jack is 9 years old. Jack went to school today. Jack is in grade 3. Jack has a pet lizard. Jack's favorite food is pasta. This is the point at which we are able to see how variables can increase the computation and processing power of our script while reducing the amount of physical coding that a programmer needs to tackle in a single script. The contents of the variable may be changed as required to effectively manipulate the output of an entire script For example, if we are required to cater for Sarah's personality, we simply need to change the information in one place, and that is the variable. Name is equal to Sarah. Print. Name plus is 9 years old. Print. Name plus went to school today. Print. Name plus is in grade 3. Print. Name plus has a pet lizard. Print. Name plus S favorite food is pasta. And the output delivered by the program will be directly affected and provided as expected. Notice, in the second execution of the script, we have Sarah's personality, which displays, and all we did was change the name variable, which was storing Jack, to Sarah, and notice how it prints us a new student's personality, and we only changed it in one place, and that was the variable. Within this tutorial, I would like to mention that we are not limited to storing only strings in variables. Our possibilities are endless. For example, suppose we had to change the previous paragraph, the one about the personality, to reflect changes for students of different grades, different pets, or different foods. You may create variables to store any piece of information and for any data type, be it strings, integers, floating points. Let us increase the versatility of our script. To begin, I have created more variables as follows. Name is equal to Sarah, grade is equal to 3, pet is equal to lizard, food is equal to pasta. You will realize that three variables hold information of string data type and one holds information of integer data type. As I mentioned before, strings are not the only data type that a variable can hold. I encourage you to test, try, and play around with the concept of variables to explore the use cases and features of them in the Python programming language. After creating my variables, I have added them into the script as follows. Print name plus is 9 years old. Print name plus went to school today. Print name plus is in grade plus string grade. Print name plus has a pet plus pet. Print name plus s favorite food is plus food. In the image above, you will be familiar with 4 out of the 5 lines of code present. I would like to bring your focus to line 15. You may wonder as to why the grade variable was enclosed in a string function. You see, do you remember the process of casting which we learnt in a previous lesson? If so, you will recall that casting is a process of converting information from one data type into another data type. In our scenario, you may have realized that the grade variable is actually holding information of integer data type because it is storing a whole number. And the point is, in Python programming, you cannot add a string to an integer. It is the same as me asking you to tell me the sum of A, B, C, D string and 500 integer. See, it just won't be feasible. But if I asked you to tell me the sum of string A, B, C, D and string 500, you would easily do it because it is a matter of string concatenation as we have learned previously. Again, I repeat, you cannot add a string to an integer in Python. You will be required to cast the integer into a string using the string function keyword. With that being said, by us enclosing the grade variable in a string function, we aim to effectively convert the grade variable, or its contents rather, into a string data type, and thereafter append it to the corresponding space in the statement. This will allow for the statement to be in proper English. So the full script of code that I have is